All right, hey you guys. So we're going to be starting to talk about the content for this course, and we're going to be looking at the first unit, which is called Thinking Geographically. All right. So there are a couple of big ideas in this unit that we're going to have to attempt to answer by the end, even if we do go pretty fast. But anyways, here in AP Human Geography, there are three themes that we need to be aware of: patterns, spatial organization, impacts and interactions, spatial processes, and societal change, right? And every unit's gonna attempt to answer one question that falls under these categories. So for instance, we'll attempt to answer why do geographers study relationships and patterns among and between places? How do geographers use maps to help them discover patterns and relationships in the world, so on and so on, all right? So just bear that in mind. Okay. Some background information before we jump into maps here, all right? And this is something you should have read in your textbooks here, but you should have read geography as a field of study, right? The history of geography, right? So geography, Greek word, right? If we break it down, there's geo and graphy, and that refers to earth writing. So really what geographers do is write about the earth, draw about the earth, so on and so on. And geography as a whole has two main subfields: the physical geography and human geography. And we're going to mainly be looking at human geography this year, right? Spatial characteristics of humans and human activities, or the why of where. And geography, human geography, sorry, and specifically is the why of where. So we're looking at why are things where they are, how did things become distributed as they are, what is changing the pattern of distribution, what are the implications of spatial distribution for people. So if you're not sure what these words mean, that's totally fine. We're going to be learning as we go along, all right? But let me just give you an example so that you have an idea of where it is. So if we were going to look at this question, what is changing the pattern of distribution? We could substitute distribution, for example, the number of people in the United States, right? So why are some people moving in certain places? Why are people leaving certain places? So on and so on, okay? Or how did things become distributed as they are? So coronavirus is a perfect example. How did the coronavirus start in China and then move all the way here to the United States and spread? So another important key aspect here for some background is understanding geography in conjunction with history. So if historians look at time to understand the past, geographers look at space, not space as an outer space, but space as in, the world around us, right? The space between one place to another. So like Portland, Seattle, everything in between, all right? And in geography, there are 5 major themes. And while these themes could be units on their own, they're kind of integrated into the units we're going to study. So movement, how has location been affected by the flow of people, goods, and ideas? Location, where is something? Interaction, how have humans and the environment affected each other? Place, how can a location be described? All right, so these are overarching themes within each unit. Awesome. So we're in topic 1.1 now. Finally, introduction to maps. All right, the basic tool that all geographers use. So by the end of this lecture, hopefully you'll understand that geographers use maps and data to depict relationships of time, space, and scale. All right. And a map could look at several things, right? Data as well. It could look at your backyard, your neighborhood, for example, your town, your county, your country. So the scale of a map can vary between all of these, and sometimes they can go even deeper and smaller than just a yard. Okay. Learning objective as well. You should be able to identify types of maps. So by the end of the lecture, you should be able to look back at these maps and say, oh yeah, this here is a choropleth map, or this here's a reference map. So that's the point. And you'll also be able to understand the types of information presented in maps and the different kinds of spatial patterns that are in maps, all right? Cool. So let us start with 1.1A1. So first of all, let's define a map, you guys. What is a map? A map is a two-dimensional or flat-scale model of Earth's surface or a portion of it, all right? What is the art of map making called? It's called cartography. All right. In the past, the makers of maps used to do it through handwriting, but now with all the technology available, it's done through satellite imagery and computers. All right. And maps have two purposes, as you might have read. They are a reference tool and a communication tool. Reference tool just to know where something is or where to go somewhere quickly. Communication tool, right, to describe the distribution or density of a certain thing like population or the coronavirus, right? And all maps are shown as projections, so they're not an accurate representation. All maps are not fully an accurate representation of the Earth, and there are reasons for that, and we'll get into that. But why? It's because the Earth is a sphere, and if we try making something 3D to 2D, it's never really going to match up, and we'll look more into that. Okay. Okay. So if you're going to take notes, now would be the perfect time to take notes. All right. So there are two types of maps. You've got reference maps and you've got thematic maps. All right. Reference maps are named exactly that because they're designed for people to refer to general information about places. Right. There are two main reference maps: political and physical. Political maps are exactly what they sound like. They show the human-created boundaries like countries, states, cities, capitals, counties, sometimes streets, all right? The physical map, right, they show natural features like mountains, rivers, deserts, all right? And while geographers do use reference maps for some important cases, geographers mainly use thematic maps, and that's what we'll be using all year. All right, but let me show you some examples here. So as you can see with these political maps, this one here is showing all the states in the United States, the countries of Europe, and the different, I'm not going to say counties of India, but the equivalent to that. All right, physical maps showing terrain and elevation. I'm sure you've seen these in your atlases from middle school. All right, I have one in my room. Of the world, a physical map of the world. All right, and then some other reference maps are pretty simple, you guys. The Tri-Minute Rail System, for example. You've got a road map here. You've got a locator map from Google Maps. All right, so these are all reference maps. I'm pretty sure you're most familiar with the Tri-Minute map. Okay, so if those are reference maps, what are thematic maps? Thematic maps basically show spatial aspects of information, right? So like it could be the number of people in a certain area or a certain phenomenon. It could even be something like what state was it mainly Democrat, Republican? So there are examples. Or like this one showing motor vehicle fatalities in 2008. All right. But there are certain kinds of thematic maps. Number one is a choropleth map. And the choropleth map uses various colors or shades of one color or patterns to show the location and distribution of a certain data. In other words, a place gets a certain color to show a certain value of something, all right? And usually the darker the color of something, the higher the statistical value, all right? So like dark purple here would be 19 to 30 numbers of fatalities per 100,000. All right. So here's another example of a choropleth map. So this is from the 2016 US presidential election, and this is broken up by counties, and we can see which counties in the United States voted mainly Republican and which ones mainly voted Democrat. And the key isn't here, but usually all maps will have some sort of key like this one. All right. Perfect. So the second type of map is a dot distribution map. And these are used to show the specific location and distribution of something across the territory of a map, all right? So usually each dot, the same size, represents a specified quantity. So if we're looking at this map here, one dot represents 100,000 people, all right? So you could take a moment to pause here and ask and answer this question. What patterns can you find in this dot map? All right, number three is a graduated symbol map. This is similar to a dot distribution map in that it uses a circle. Well, most of the time it uses a circle. But first of all, let's define graduated. So graduated, arranged in a series or according to scale. All right, so we can see here that the bigger a circle, the greater the number, the smaller the circle, the smaller the number. All right. So a graduated symbol map uses symbols of different sizes to indicate different amounts of something. All right. And this here is looking at US oil consumption. And then lastly, and one that we probably won't use often, is an isoline map. This is basically a type of map that uses lines that connects points of equal value and depicts variation in data. So think of elevation, for example, all right? The closer the lines are, change is rapid, and where the lines are farther apart, the phenomenon is relatively the same, all right? So if we look at this blue here, this is representing a lake, all right? So it looks relatively the same. The lines are farther apart. The closer together, maybe like this one here, probably the greater the elevation. All right, and the last type of thematic map is a cartogram. And a cartogram is a little bit unique in that the sizes of certain places won't really fall in line with what a regular map would show. So the sizes of countries, for example, would be shown according to some specific statistic, right? So let me show you some examples, right? You got this cartogram here that shows the world's immigrant per country. The larger the countries on the map, the more immigrants it has. Here's another cartogram for you. It shows the world's immigrants per country. So the larger the country is on the map, the more immigrants it has. And immigrants are people who leave the country. All right, so obviously it's still showing the world, but in a very unique way. And there are other fun types of cartograms that you could look at, right? Like you got this one from Walmart, the number of Walmarts in the United States, the number of McDonald's in the United States per state, Starbucks, or looking back at the 2016 US presidential election. I mean, if you ask me, this would show a greater number of Democrats who voted as opposed to Republicans, which is very different than, if I can go back here, very different from this map, which would somehow show that Americans mainly voted Republican. So types of maps show different types of information, and in a sense, at least in politics, could give off a certain bias, all right? But we'll look more into that in a different unit. For now, we're just looking at the type of maps. Okay, so those are your types of maps. So let's look into the next subtopic here in 1.1, A2. And we're going to be looking at the types of spatial patterns on maps, all right? And what do I mean by spatial patterns? What I basically mean by spatial patterns is certain kind of specific data, like numerical data that you could find on maps, right? Numerical or qualitative data, right? So things like absolute and relative distance, direction, location, clustering, dispersal, and elevation. All right, and we're going to break this down. So your first type of spatial pattern on maps would be location, all right? Absolute location in particular. So we're going to be breaking this down, by the way, between distance, well, location first, and then we'll be doing distance and then direction, okay? So we got absolute location, and absolute location is the precise spot of where something is, right? Like latitude and longitude, a specific number, or an address. Like your address would be an absolute location, right? In that same sense, we got absolute distance. And absolute distance is a distance that can be measured, using a specific unit of length, right? So like 5 miles or 3,000 feet or 20 kilometers, right? These are things that are represented on maps, right? And sometimes they're clear cut. Sometimes we have to really look at a map and be like, oh yeah, it's right there, because sometimes it's pretty small to see. All right, but these are what define a map, all right? The grid, this is a spatial pattern represented on a map, right? And the grid is basically referring to the latitude lines labeled north or south and the longitude lines labeled east or west. And both are 15 degrees apart from the next line, right? So 40, 60, right? This one is actually 20 for some reason. Okay. Let's break it down. So latitude. Latitude is the distance north or south of 0 degrees, or the equator, and they're called parallels as well. So the equator, an important line to know, but just notice that each of the latitude lines is 15 degrees north or south of each other. All right, I always like to think about latitude as flatitude, right? Because at least if you were to put in 2D, this line would be horizontal and, at least in my mind, flat. Okay, but the lines of latitude are not equal in length. As you can see, the more north or south you go, the shorter the lines are as they approach the north or south pole. Okay. All right, and then longitude is distance east or west of 0 degrees, okay? And they're also called, the longitude lines are also called meridians, all right? Equal length arc, not lines, they converge, they meet at the poles. So remember, the lines of latitude do not meet because they're parallel, all right? And so here are some important arcs for you to know. The prime meridian, all right? So the prime meridian, as we can see here, 0 degrees. That basically runs through Greenwich, England, right? So say as Greenwich, not Greenwich. Sounds like sandwich, right? All right, the International Day Line is another important arc to know. The International Day Line is here, right in the middle of the Pacific Ocean. Well, somewhere in the middle. All right, and note that the prime meridian and the International Day Line separate the Earth into eastern and western hemispheres. So if you wanted to know where the exact cutoff point was, now you know. And another interesting thing about longitude lines is that they also tell us about the time of a place, right, or the time zones, right? So each time zones are separated by 15 degrees east or west, right? So if the Earth is 360 degrees, we divide it by 24 time zones, that's 15 degrees per hour. All right, so you could pause and think here. Why do you think Greenwich was picked to be 0 degree longitude? Right, if you're really interested, you could click here to read about the topic. All right, and by the way, the International Day Line here, this is basically the line that separates, at least where we are, tomorrow and today, right? Today, tomorrow. All right. So a quick progress check for you guys to answer this, and thinking about absolute location, right? And that's one that I think merits a question of its own. So which statement do you think best describes the absolute location of Paris, France? Okay, so remind yourself, what is absolute location? So we have absolute location, absolute distance, but there's also such a thing called relative location and relative distance. And this can be a little fuzzy for some people. I know it was fuzzy for me in the beginning, all right? But let's define it. Relative location, it's where something is located in relation to other things. So for example, Orlando, Florida is located north of Miami and south of Jacksonville, right? If we use Portland, Oregon as an example, we could say Portland, Oregon is north of Corvallis, Oregon, and south of Seattle. Here's another example. The bank is located next to Target. Another example, it's next door to my house, or like the bike is next door to my house. I don't know, something like that, okay? Relative distance, all right? Relative distance is measured in terms of other criteria like time or money. So instead of saying like New York to Paris is a certain number of miles, you would say in terms of time, like it takes 7 hours to fly from New York City to Paris, France. Or in terms of money, a ride share in New York City from Manhattan to LaGuardia Airport is $40, right? Another example, I'm pretty close to home. I'm across the ocean, right? So you're not using a set measurement. Okay. And then there's direction, relative direction, and absolute direction. Let's start here in the right with absolute direction. Absolute direction is pretty easy. You're just using the cardinal directions, northeast, southwest. While relative direction, you're using things like left, right, up, down, front, or behind. All right. So an example, I'm on the other side of the store from you, or I'm right behind you, right? I mean, right behind you could be like 2 feet or like 30 feet. So really depends on people's perception. So another personal progress check here for you, all right? Which statement describes the relative location of Barcelona, Spain? All right. So go back, look at relative location, the definition. Okay. So what else is represented on a map, right? We looked at location, we looked at direction, we looked at distance. Now we have to look at scale, all right? Scale, it can be tricky at first here, all right? But first, let's look at a map in general, the map scale. So if maps are a reduction of the actual land it represents, a world map is not the size of the earth, right? No, all right? Well, sometimes it's not, all right? But scale is the ratio between the size of things in the real world and the size of those same things on the map. So there are 3 types of scales when we look at a map: cartographic, geographic, and the scale of data. So a cartographic scale, even though it has a fancy word there, it's not too difficult. It's something I'm sure you've seen on maps all the time. And it's something that can be learned easily, all right? But a cartographic scale refers to the way the map communicates the ratio of its size to the size of what it represents. So for example, 1 inch equals 10 miles on a map. Or if it was in a ratio, 1 inch equals 200,000 units of something on the ground. Or it could be in a line like this here, right? Where the length of the line indicates the distance of a map. So like, for example, we could say that this 1 inch here represents nearly 1,500 miles, okay? And note that the smaller the scale, the larger amount of area is covered and the less detail you'll get, okay? So let's look at geographic scale now, all right? Sometimes it's also called relative scale. It refers to the amount of territory that the map represents. So global scale means a map of the entire planet. The local scale means the map of a city, all right? Trying to think of an example here. A regional scale, for example, could show North America, all right? And here's a question to ponder. Why might a rise in unemployment might be explained differently depending on the scale, all right? Like you could look at unemployment as a whole in the United States, but then you could look deeper into like unemployment in New York versus Alabama, for example. And lastly, the scale of data. So if you look to the right, you'll see 2 maps of Australia, exactly the same size. But the scale of both maps is different, all right? So take a look at it. What conclusions about the population density of Australia can you come up with? So think about it. I mean, if we look at Australia here, population density, we would think, at least if we looked at it on a national scale, right? Because Australia is a country. I mean, we would think that population is evenly distributed across the country. But then if we look here into territory, state and territory level, we'll see that population isn't evenly distributed as this map here. We'll see that population is mainly centered here in this part of Australia, while the western part of Australia isn't as dense in population, all right? So we looked at absolute distance, direction, location, relative distance, location, scales of a map. So let's look at the last few patterns that are shown on maps, right? Clustering and dispersal in particular. And these are just other words for other words. So clustered versus dispersed, it's basically data that's grouped versus data that's scattered, or data that's concentrated versus data that's distributed, right? Clustered is basically the closer a certain data is on a map. And dispersed is exactly what it sounds, the farther apart the data is on a map. Okay. So let's look at some examples that actually show cluster data versus dispersed data, right? If we look at city clusters here on this map, we'll see that most cities are pretty clustered together, right? Or the other word we would use is grouped or concentrated, right? So the data here is concentrated. It's not dispersed. I mean, Greenland, it would be dispersed, but the data here is concentrated, right? Again, if we look at this map, we'll see that data here is concentrated or clustered, right? But then if we're thinking about data that's dispersed, scattered, or distributed, we'd be looking here at Brazil, right? I mean, these two cities are pretty far apart. Africa, cities with at least 1 million people are farther apart. Right, if we look at this city, this image, right, it's pretty clustered together, heavily populated. Well, if we look at this small rural town, it's pretty dispersed, right? The homes are farther apart compared to this. All right. And if we're looking at another map of COVID cases, we'll see, and this is an isoline map, by the way, if you didn't know, right? The data or the concentration of COVID cases here is pretty concentrated, pretty clustered. While here in these areas, they're pretty dispersed. Okay. So the last type of data that's shown on maps is elevation, all right? And we won't see this often. Mainly it's something used by weathermen, for example, or hikers when they hike a mountain or a certain trail. All right. Cool. So those are the types of patterns, the types of data that are represented on maps, all right? So we looked at types of maps. We looked at the spatial patterns on maps. And now we're going to move on to the last subtopic of unit or topic 1.1. And that is map projections, all right? So all maps are selective in information, all right? There are hundreds of maps out there, right? Types of maps, all right? And they all show, and they're all made for a certain purpose, all right? But map projections inevitably distort spatial relationships in space, or shape, area, distance, and direction, okay? So here's the definition of map projection, right? And you can read it there. The process of showing a curved surface on a flat surface, so taking a 3D object and making it two-dimensional. And it's pretty hard to do that. Actually, it's impossible. It's been mathematically proven that you cannot replicate the Earth, the globe, on a 2D piece of paper, all right? So if you look at the grid on the globe, you'll notice that they're not perfect squares like the map we're used to seeing, right? So smaller squares here, right? More, quote, regular size maps here. So the flat image will be distorted, all right? And there are 4 distortions on any map projection. We can use the acronym SAD for that. Shape is distorted, right? The shape of countries. The area is distorted. The distance between countries and the distance of a country is distorted, and the direction. So it's important to understand that every projection has distortion, but at least one part of SAD is being preserved on a map projection. So on every map projection, there is some type of distortion, either with shape, area, distance, or direction, but one of them is preserved. And the reason why the globe can be perfectly shown on a 2D map is because the globe isn't a perfect sphere. All right, this is what the globe looks like if you were to look at it at a distance, and you were able to see the whole thing, right? You can easily tell it's not a perfect 360 globe, right? This part seems to be stretched out, if you ask me, but that's what the globe looks like, if you're wondering. Geoid. Okay. Anyways, let's go over some of the major projections that geographers use to understand that they use, right? So the first one is the Mercator projection, right? And the purpose of the Mercator projection is navigation. Now this is a map that you've all probably seen, whether you know it or not, like you know the name is the Mercator projection. It's a map that I have in my classroom. And I mean, I found it. So most schools, American schools, have been using the Mercator projection. So it's not that I chose it on purpose. It's just it's one that I found. But the strengths of the Mercator projection are the fact that directions are accurate, right? I mean, if you look at the latitude and longitude lines here, they're pretty even here. I mean, once you get closer to the poles, they're a little bit distorted, but for the most part, directions are accurate. And like I said, the distortion here is that distance between the lines of latitude appear consistent and the land masses near the poles appear large. Okay, Peters projection. So this is one that you probably haven't seen before. And if you compare the two, they look very different. I recommend you look at Greenland and Africa as a reference point. But the purpose of the Peters projection is so that spatial distributions related to area are pretty accurate, right? So that means that the sizes of the land masses in the world are pretty accurate, right? So Africa should be looking this large when you compare it to Greenland, right? The United States should be the size of the Sahara Desert. The distortion here is that a lot of the shapes are inaccurate, especially near the poles. Like if you look at Brazil, that looks really stretched, right? So here's the Peters projection over the Mercator projection. So again, as I was saying, look at Greenland and Africa as your reference point. Quite different. Third type projection is the conic projection, all right? So the purpose, general use in mid-latitude countries, strengths, the lines of longitude converge, lines of latitude are curved, size and shape are pretty close to reality. The only distortion here is that directions are not constant and longitude lines converge at one pole, all right? So it's not showing the South Pole. Another example here, the Good-Hommelson projection. Spatial distribution is the purpose, area and shape are preserved, but the distortion here, the oceans, you can see Greenland is cut off. And lastly, the Robinson projection. So the strengths here is that size is closer to accurate. Ocean sizes look more accurate, no major distortion. The oval shape appears more like a globe than a rectangle, right? So you can see the little curve here. The only problem with this map is that Antarctica looks humongous. It should not be that large. Greenland looks flattened north to south. So size, area, distance, direction, they're all slightly distorted in some way. All right, cool. So you guys, that is it for the lecture for 1.1. There's a lot to go through, okay? But the assignment that you have that you're gonna be completing on Schoology will force you to look back at these notes and you'll be able to understand the things we've learned here today, right? The thematic maps, the projections. So yeah, you're going to be watching this video. It's linked on the Schoology assignment page. So please watch this. It'll explain a little bit more about map projections and basically what I said, that all world maps are distorted and in a sense all of them are wrong. Okay. But yeah, if you have any questions on anything in the lecture, please email me and I'll be happy to answer. All right.